Hello, Math Wizards! Welcome to a new lesson episode of Just Math PH. So for today's lesson, we will be learning about sum and product of the roots. We have here an example of a quadratic equation, which is x squared plus 4x minus 12 equals 0. The roots of this quadratic equation is equivalent to negative 6 and positive 2. So this can be solved using Vedic method or quadratic formula. Now, we want to find the sum of the roots. We know that sum is the answer for addition, meaning we have to add negative 6 and 2. So let's find the sum of the roots. Negative 6 plus 2 is equivalent to negative 4. Remember that adding unlike signs or unlike sign numbers, we have to subtract the numbers and then copy the sign of the bigger number, which is 6. So we have to follow the sign of 6, which is negative. That's why the answer is negative 4, or our sum is negative 4. How about the product? We know that the product is the answer for multiplying numbers. So we will multiply the roots. Negative 6 times 2 is equivalent to negative 12. So the sum is negative 4 and the product is negative 12. So we can find the sum and the product of the roots here if the roots are given. Suppose we just want to know the sum and the product of the roots without actually knowing the real values of the roots. Do you think we can do that? Okay, for example, let's use the same example, x squared plus 4x minus 12 equals 0. Suppose we do not want to know the values of the roots, but we just want to know the sum of the roots and the product of the roots. So, for us to do that, the values of a, b, and c of the quadratic equation will help us determine the sum and the product of the roots. So sum is actually denoted by negative b over a. And the product of the roots is denoted by c over a. So let's find the sum of the product of the roots by the help of the values or the coefficients of our quadratic equation. So a is equivalent to 1, b is equivalent to positive 4, and c is equivalent to negative 12. So the sum is equivalent to negative b over a, or the sum of the roots is negative b over a. So let's substitute b and a. Remember that we have here a negative first, so negative b, which is 4, so negative 4 over 1. Negative 4 divided by 1 is equivalent to negative 4. How about the product of the roots? So which is c over a. So c is negative 12 divided by a, which is 1. And negative 12 divided by 1 is negative 12. So our sum of the roots is negative 4, and the product of the roots is negative 12. So you see, we do not know the roots of this quadratic equation, but we know that the sum of the roots of this quadratic equation is negative 4, and the product of the roots of this quadratic equation is negative 12. Now let's see if we got the same value for the sum and the product of the roots, if the roots are given and if the roots are not. So obviously we have the same answers. The sum is negative 4 and the product is negative 12. So remember the formula for the sum and the product of the roots. If we just want to know the sum and the product of the roots without actually finding the values of the roots. So the sum is denoted by negative b over a, while the product is denoted by c over a. So let's have the first example. Find the sum and product of the roots of the quadratic equation x squared minus 5x plus 6 equals 0. So let's solve this. So we have the quadratic equation x squared minus 5x plus 6 equals 0. We know that the sum of the roots is denoted by negative b over a, while the product of the roots is denoted by c over a. Now, let's first determine the values of a, b, and c here. So our a is 1 because there's an invisible 1 here. Our b is negative 5. And our c is positive 6. So substituting the values of a, b, and c for the sum and the product of the roots. So for the sum, we have negative b, so negative, meaning I am writing this negative here. Then our b is negative 5, so that is negative 5 over a, which is 1. So negative times negative 5, that is positive 5 over 1, which is equivalent to 5. So our sum is 5. Okay, now how about the product? Okay, our product is c over a. So c is 6 divided by a, which is 1. 6 divided by 1 is 6. So our product is positive 6. Number 2. Find the sum and product of the roots of the quadratic equation 2x squared plus 8x minus 10 equals 0. So for our solution, so let's write 2x squared plus 8x minus 10 equals 0. So let's determine the values of a, b, and c first. Our a now is 2, our b is 8, and our c is negative 10. So let's find the sum of the roots, which is negative b over a. So negative b, which is 8, divided by a, which is 2. Negative 8 divided by 2, that is negative 4. So our sum is negative 4. Okay, how about the product? So product of the roots, okay, product of the roots is c over a. So c is negative 10 divided by 2. The answer is negative 5. So the product of the roots is negative 5. Did you know that we can use the sum and the product of the roots to form a quadratic equation? We can use the relationship below. X squared minus the sum of the roots, which is R1 is our first root, plus R2, our second root. Obviously, this is the sum of the roots, times X, plus R1, R sub 1 times R sub 2. This is obviously the product of the roots. So here, the roots are given. So for example, form a quadratic equation given the following roots. So we have here the first example. The roots here are the following 7 and 5. So it's up to you where is your R sub 1, where is your R sub 2. So you can denote this 7 as your R sub 1. So this could be your R sub 1. And 5 could be your R sub 2. Or 5 could be your R sub 1. 7 could be your R sub 2. It's up to you. It doesn't matter. So using these roots, these are our roots again, we will form our quadratic equation. So using the relationship above. So let's write the quadratic equation. So this is x squared minus r1. So r1 is 7 plus r2, which is 5. Then we will copy x plus r1 times r2. So 7 times 5. Okay. So let's simplify this. This is x squared minus 7 plus 5. So 7 plus 5 is 12. X plus 7 times 5 is 35. Okay, do not forget equals 0. Equals 0 because this is an equation. So our quadratic equation is x squared minus 12x plus 35 equals 0. For second example, form a quadratic equation given the roots -2/5 and +3/4. So remember that if the roots are given, we can form the quadratic equation by this relationship, x squared minus the sum, that it is the sum of the roots. So we just have to add the first root and the second root, so that is our sum. And then write x plus the product. It means we have to multiply our roots here, and that would be our product. Do not forget equals 0. Now, since we have here fraction, roots are fractions, it's easier for us if we find the sum first. Okay, so let's determine the sum first. That is adding -2/5 plus 3/4. Okay, so let's review adding fractions. Now, we have here the numerators -2 and 3, and the denominators 5 and 4. Since we have dissimilar or not the same denominators, 5 and 4, our denominators are not the same, we have to find their LCD. Okay, LCD. So how do we determine the LCD? So a little review. Okay, so LCD is the least common multiple of 5 and 4. So for us to easily find multiples, let's write the multiples of 5 together with 4. So what are the multiples of 5? So we have 5, 10, 15, 20, and so on, right? How about 4? What are the multiples of 4? We have 4, 8, 12, 16, 20. Okay, now stop. We have to stop because we have found the least common multiple of 5 and 4. And this will be our LCD. Okay? So our LCD is 20. So what we will do, we will combine these two fractions using our LCD 20, and then we have to divide 20 by the first denominator here, which is 5. 20 divided by 5, you have to divide it here. 20 divided by 5 is 4. Now 4 times, okay, multiply above. 4 times -2, that is -8. Again, 20 divided by 5, that is 4. And 4 times -2, that is -8. Okay, now let's go to 4. 20 divided by 4, that is 5. Okay, divide, that is 5. And then Going up, 5 times 3, that is 15. So positive 15. Okay? So we will add negative 8 and 15. So obviously, adding unlike signs, we have to subtract and then copy the sign of the bigger numbers. So 15 minus 8, that is 7. 7. So we will follow the sign of 15 because 15 is bigger than 8. So it will be positive 7 or just 7. And then copy the denominator 20. So we have the sum of the roots, 7 over 20. Okay? Now, how about the product of the roots? So the product of the roots is just multiplying our roots, negative 2 over 5 times 3 over 4. So negative 2, multiply it to 3. So that is numerator times the numerator, denominator times denominator. So numerator, negative 2 times 3, that is negative 6 over 5 times 4, that is 20. So since this can still be reduced, we will divide it by their GCF, which is 2. So divide negative 6 by 2, that is negative 3. And 20 divided by 2, that is 10. So negative 3 over 10. So our product of the roots is negative 3 over 10, while the sum of the roots is 7 over 20. So let's write the relationship for the quadratic equation. So the relationship, remember that the relationship which we will be using to determine the quadratic equation or to form the quadratic equation is given by x squared minus the sum x plus product equals 0. Do not forget the 0. Okay, so let's apply that one and let's form our quadratic equation. So that is x squared minus, our sum is 7 over 20. So minus 7 over 20, copy x, and then the product minus 3 over 10 equals 0. So this is our quadratic equation. So actually, this quadratic equation can still be simplified or reduced. However, I will discuss this later on.